Hello there, good day. Welcome to our summer coaching series, and this is the second lesson for senior secondary school 2, and it's a continuation of the first lesson, which is approximation. We learned how to approximate numbers to the nearest billions, tenths. We also learned decimal places, how to round up numbers in the nearest one decimal place, two decimal places, and so on and so forth in the last lesson. You can go back to the last lesson if you are just joining us. Now, first thing, today we're going to be looking at significant figures. Significant what figures? Significant figures for significant figures. How to round off numbers to significant figures. That's the focus of today's studies. Now, this lesson, don't forget that in the last lesson we learned that numbers 0, 1, 2, 3, 4 they are rounded down, while 5, 6, 7, 8, 9 they are rounded what up. Rounded down means that they add nothing to the previous number, while rounded up means that they add 1 to the previous number before them. So let's look at this. Significant figures. How do we round off to significant figure? The first thing, imagine you had this 8.026. Now this is the decimal that is greater than 1. This is the decimal that is greater than 1. For decimals that are greater than 1, the first significant figure is this, the first digit. The second significant figure is the second digit. The third significant figure is the third digit, and so on and so forth. For decimals that are greater than 1, meaning that a decimal that is greater than 1 is such that rather the first digit here is to be greater than 1. You know, a decimal is made up of two parts. A decimal number is made up of two parts. The part before the decimal point and the part after the decimal point. If the part before the decimal point is less than 1, it is the decimal less than 0. This, for instance, this decimal is less than 0 because this part that is before the decimal point, which is known as the whole number, is what? 0. While this part is what? Greater than 1, which is 8. So to round this up to 3 significant figures, it will be approximately equal to, don't forget this symbol. You go to the third significant figure, which is 2. Now, you will not use the third significant figure, you go to the next number after the third significant figure, which is 6. Do you round up or round down 6? You round up 6. So 6 itself will be 0. Then because it's rounded up, if you add 1 to these two, it will be then it will be what? 3. You have 0.8. I call the number backwards. And we also said that this last 0 after this decimal point, as long as there is no non-zero digit after it, it is insignificant. So this is our value. This is our value. So this is approximately equals to what? 8.013. Now, in contrast, if you have a decimal that is less than 1, this decimal is greater than 1. If you have a decimal that is less than 1, please take note that the first significant figure is not this 0, it's not this 0. The first significant figure is a non-zero digit. This is the first significant figure. Let me add this to it. This is the second significant figure, and this is the third significant figure. For a listen, take note. For a decimal that is less than 1, meaning that the first digit is 0. The first significant figure will be the first non-zero digit, the first number that is non-zero. Imagine this, if you have this 0.0000523. Now, what the first significant figure is? The first significant figure here is this. The second significant figure is this. And the third significant figure is this. The first non-zero digit. But if you have this 1.300059, because this decimal is greater than 1, it's not greater than 1. The digit here, the whole number here, the digit before the decimal point is not 0. It is 1. So it does mean that this will be the first significant figure, second significant figure, third significant figure, and so on and so forth. So please take note of that. That's the difference. And let me go into another example. Let me go to another example. Let me deal with decimals first. If you have this 0.00024, okay, just 2487. Now if you want to round this up to one sigma figure, what the first sigma figure is 2, the second sigma figure is 4. So let me write this digit again. First sigma figure, second sigma figure, third sigma figure, fourth sigma figure. So to round up to one significant figure, you go to the first significant figure, which is 2. Then what's the next digit after 2 is 4. Do we round up 4 or round down 4? If we round down 4, 4 itself will be what? 0. And the other digit after it will be 0. Now, because we round down 4, 4 we add nothing to this, so you have 2. And let me write the digits that were before. So these zeros after it, they are insignificant. Please take note that these zeros here, the zeros this 0 and this 0 before this non-zero digit, they are significant. But this other 0 after this non-zero digit, not 0 number, meaning number that is not 0. So this is the answer. Please, this is approximately equals to. So this is approximately equals to 0.02. Approximately equals to 0.02. That's to one sigma figure. What of two sigma figure? We have two sigma figure, approximately two sigma figure. How do you do that? You go to the second sigma figure, which is 4. Right? It is 4. Then you use the number after 4, which is 8. Do we round up or round down 8? We round up 8. So since we are rounding up 8, 8 itself will be 0, and the next digit after is 0. Because you are rounding up 8, if we add 1 to this 4, it becomes what? 5, 2. 0, 0.0. So this will be approximately equal to 0.0025. That's the sigma figure, and so on and so forth. That's the way to go about it. The key is just to know that if you are dealing with decimals that are less than 1, that means the number before the decimal point is 0. The first sigma figure will be the first number that is not 0, the first non-zero digit. While if you are dealing with decimals that are greater than 1, that means the first digit, the whole number part of this decimal number, the first digit that is before the decimal point is greater than 1. Meaning that is the first sigma figure, this is the second, this is the third, and this is the fourth, no matter if there are zeros after it. Then also, take note that you can also approximate this to sigma figure 450,170. You can approximate this to sigma figures too. Let's approximate this to 3 significant figures. Now when you have this number, this is the first sigma figure, this is the second sigma figure, and this is the third sigma figure. Keeps going like that. This is the first. The only exception to sigma figure is this. The first non-zero digit is the first sigma figure when you have the decimal that is less than 1. But when you have this is the first sigma figure, second sigma figure, third sigma figure, fourth, fifth, and sixth. So if this is the third sigma figure, we have to use this next number, which is 1. Are we rounding up 1 or round down 1? We round down 1. If we round down 1, 1 will become 0. Round down 7, 7 will become what? 0. Okay. What did I just say? Sorry. If you round down 1, 1 will become what? 0. Then this other digit will be what? 0. Please forgive me. You round down 1, 1 will become 0. All the other digits will be what? 0. Then if you add 1 to this, this will be 1. No, it won't add because we've rounded down. Please. Sorry. Let me say that again. I'm sorry. So we want to round this up to 3 sigma figure. You go to the third sigma figure, which is 0. The number after it is 1. So if you round 1 down, it becomes what? 0. And the other numbers after it will be what? 0. Because you rounded it down, it will add nothing to this 0. So you have 0, 5, 4. So this is 450,000 in 3 significant figure. 450,000 in 3 significant figure. That's the answer. 450,000 in 3 significant figures. So that is it. Now let's see this. You can as well, don't forget, like I said in the last lesson, You can rewind back to right if I'm moving too fast for you. You can rewind back, pause, right, then play the video. It's at your own pace. Now let's go to estimation. Now this, I said that in the first lesson. The estimations are very important. Approximation and estimation, they are related, and they are very, very important because imagine you are getting paid this amount after tax per month. Now if you are to calculate how much you be paid in a year, it will be times 2, right? Times 12 rather. It will times 12, right? Because there are 12 months in a year. 2 times 7, 14, 1. 2 times 8, 16, 17, 18, 19, 4, 5, 2, 7, 8, 9, 2, 1. So let's add 4, 4, 18, 15. So this is how much you'll be earning roughly in a year. This is how much you'll be earning roughly in a year, right? But you know, you can do this. Instead of you calculating this, you can say I earn estimatedly 13,000, because you can run this up to the nearest 10. Let's say 10, nearest 1,000. Yeah, nearest 1,000. Is it 1,000? Yes, nearest 1,000. Yeah, nearest 1,000. You can run this to the nearest 1,000. So if you now run this up to the nearest 1,000, it will be 13,000. You should take note that this, it just needs about 13 digits to get to 3,000. If you add 13 to this, you get to 13,000. If you add 13 to this, yeah, you get 13,000. So you can also round it up to the nearest 1,000 as 13,000. Then let's multiply by 12. It makes your calculation easier. 00061, 00013, 62. Okay, 00062, 00062, 000. So if you add this up, so you have 156,000. Now this is the estimated value you are making in a year. Why this is the actual value you're making in a year? You see that they are not the same. They are not the same. But because of to help you calculate easily, and to help you, let's say you want to call out how much you're earning, you can say I'm earning about 156,000. Instead of you saying I'm earning 155,844 there, you can easily call it. So that's our estimation. That's why it is important. And there are some times where when we're dealing with data, we use estimated values. We use estimate. We approximate and use estimate. If you find the mean ages of students, it's possible for you to get a decimal fraction. Let's say the mean ages of students is 20.6. It will be better for you to say the mean age of students is 21 in some instances. Or I think this will be the best example to use. We want to find the mean age births, the mean amount of children that are being birthed in a community. That means how many, the mean amount, the average amount of births that are in the community. Now, if you have something like this, 20.667, 20.67 births can be approximately 21 births to make more sense. So estimation is very, very important because it is useful in this wise. It is useful in this wise. But please, anytime you are estimating, anytime you are approximating, let us know that you are approximating, because it still cannot replace the actual value. It cannot replace the actual value. It's close to it, but it cannot replace it. So in next class we'll move on to percentage error, because I don't want this to exceed the time limit of 30 minutes, and appears this is short. But if I move on to percentage error, that is the topic on its own. So let me give you something to do, then I would I'll be waiting for your questions, for your challenges when we have our one-on-one session. So do this. Make sure you do it. Very, very important. Make sure you do it. Round of 0.009281 to the nearest one. 2 SF, that's 2 sigma figure 1, 2, 3 SF, 3, 4 SF. In fact, let me make this 2. So you round this off to 2 SF, 3 SF, and 4 SF. You round this second one to 2 SF, 3 SF, and 4 SF. 8, 6, 1, 2, 5, 7, 8. Yeah. Then 2. Okay, look at this. Let me give this. In 2008, Nigeria's rate of oil production was 1.825 million barrels per day, million barrels per day. Give at least 3 ways this could be reported. Give at least 3 ways. I always like applied question. 3 ways this might have been reported. Then 2, use estimation to decide whether or not oil production reached 1 billion barrels. 1 billion barrels in 2008. So this is an applied question. Let me read it out. In 2009, Nigeria's rate of oil production was 1.825 million barrels per day. Give at least 3 ways this might have been reported. They use estimation to decide whether or not oil production reached 1 billion barrels in 2008. So I'll see you in the next one. Bye.